Okay, so we're going to talk about chemical names and formulas. To start off, we need to have a little vocab lesson. So one word you need to know is nomenclature, and this is basically a word that means naming system. So I'll refer to things as either like this is how we name it, or the nomenclature for this. So be used to that word. And then we also use the word stock system, and that's a naming system for chemical ions and elements. We also are going to talk about chemical formulas, and these are when we use the elemental symbols and subscript numbers, and we can show, by doing that, we can show how many of each element is in a compound. So for example, octane, hydrocarbons, so if it has a carbon and hydrogen, they get special names, and so this one's name is octane. You can see that because oct, there's 8 carbons. Don't stress out about that though, we're not going to be getting into the nomenclature of hydrocarbons. But for this one, you can see in the chemical formula, right, the subscript indicates that there's 8 carbon atoms in this molecule of octane, and the 18 next to the hydrogen indicates that there's 18 hydrogens. So this should be mostly review for you. Now when we're naming ions, when an element gains or loses an electron and becomes an ion, it gets an ionic name. So first we have cations. Think about what these are for a second. Review in your mind. And you should have, right, that they're positive ions. And they're usually metals, right? These are easy. You don't change their name. So magnesium without a charge or magnesium 2+ are both called magnesium. Easy. If the cation can have different charges, so some transition metals, then we put a Roman numeral at the end to show what charge it has. So for example, iron 2+, we would say is iron with Roman numeral 2. Right, next we have anions, and again, review what they are. And you should have that they're negative ions. These names do change. So, right, so cations, a positive ion, we don't change their name. Anions, a negative ion, we do change their name. We do this by dropping the end of the name and adding "ide." So nitrogen, we're going to drop out everything after the O, and it's going to become nitride when it has a charge. So pause here and practice with these ions I've provided you with. Write down the names. You can see the answers under Day 2 PowerPoint practice key on the class website. So now we know how to name the ions, so now we're going to name an ionic compound. Right? Ionic compounds are just big crystals in set ratios, and so we don't have to state how many of each element is in that ratio in the name. So we just do the cation name plus the anion name. So for example, here we have Al2O3. So we name the cation, which is aluminum. We name the anion, which is oxide. So right, oxygen, ox is the root name, so oxide is the ion name. So that means that this ionic compound is aluminum oxide. So here you can practice figuring out what the formula unit is for the following compounds and writing their name. So pause here and do that. Again, these answers are available on the class site. So now for naming with polyatomic ions. Polyatomic ions have special names, right? So they don't change when in a compound, and the rule is still cation name plus the anion name. So you can practice writing what the formula unit is for these two compounds. And then figuring out what the formula unit, yeah, you should already, these are the formula units, but write down their names. So pause here, and again, the answers are available on the PowerPoint key on the class site. Okay, so now that's how we name ionic compounds. Now if we're naming a molecular compound, these are, if we remember, molecular compounds are individual units of covalently bonded atoms. The amount of each type of element matters in naming, so we have to say how many there are. And we utilize prefixes to do this. So this chart goes through the common, what the prefixes are for each number, right? So 1, mono, 2, di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, 8, octa, 9, nono, and 10, deca. So these are common prefixes. They shouldn't be too big of a surprise to you to see. So when we're doing molecular nomenclature, there's 3 rules we follow. First, the less electronegative element is given first. It is given a prefix only if there's more than one of that element. The second element is named as the prefix plus the root name, and then "ide." So the "ide" is similar to ionic compounds, but unlike ionic compounds, we have this prefix coming before it. The third rule is that if there's an O or an A at the end of a prefix, it is usually dropped when the word following the prefix begins with another vowel. So for example, monoxide, we don't say monooxide, it's just monoxide. Or pentoxide, we won't say pentaoxide. Right, it just gets too stumbling. So let's practice with these. So here we have P4O10. So first we take the first element, which is the less electronegative element, and we figure out the prefix for it, and then we give the name of the less electronegative element. So here we have 4, so that's going to be tetra, and P stands for phosphorus, so it'd be tetraphosphorus. Then we take the second element, and we give the prefix number, the prefix indicating the number of atoms being contributed by the more electronegative element, and then we give the root name of the more electronegative element, and then add "ide" to it. So here we have 10 oxygen, so that would be deca for the prefix, and then the root name for oxygen is ox, so it would be then decoxide, because we dropped that A from the deca because oxygen starts with an O. So then the name of the compound is tetraphosphorus decoxide. So here you can practice naming compounds from either naming the compounds from their formula and then writing the formula based off of the names. So pause here and do that. Again, these are available, the answers are available on the class site. Alright, almost lastly, we have covalent networks. So if you remember, covalent networks are compounds that are compounds of covalently bonded elements, but instead of just being an individual unit, they are spread, they form a network, and they're bigger. They form crystals just like ionic compounds do. And so, just like ionic compounds, they get a formula. Their formula is the simplest ratio of the elements in there, but then they're named like molecular compounds. So for example, if we have SiC, that'd be silicon monocarbide, because silicon, we have only one of them, so we don't need to give a prefix, and that's our first element. And then we have one carbon, so that's where we get the mono. carb is the root word of carbon, and then we add the "ide" to it. So you can practice with these other covalent network-based compounds. And again, the answers are on the class site. Last, we have acids. So acids are a special type of molecular compound, and we're going to get more into them next semester, but I want you to get comfortable with their naming right now. We have two types of acids. So the first type is binary acids, and these are acids that consist of two elements, and it's going to typically be hydrogen and one of the halogens. For naming, we use hydro, which means from hydrogen, then the root name of the other element, and then we add ic acid. So for example, HCl, which you could call hydrogen monochloride, right? But typically you're going to hear it be called hydrochloric acid, right? So we get the hydro from the hydrogen. Chlor is the root name of chlorine, and then we add ic acid. So you can practice with HF here. Then we have oxyacids, and these are acids that contain hydrogen, oxygen, and another element. And these are usually going to be made up of polyatomic ions with hydrogen. For naming, you're going to do the root name. It's just the root name of the polyatomic ion plus ic acid. So for example, HNO3, NO3 is nitrate, so nite is the root name. We don't, because this is an oxyacid, right? Because it's hydrogen with oxygen and another element. We don't include the hydrogen, and so we're just going to take the root name of the polyatomic ion, so nit, and then add ic acid. So HNO3 is nitric acid. And you can practice with this one here. Once you're done, you can move on to the homework for tonight.